Another quantity of interest is known as the slope of a line. And so this emerges as follows. If I have 2 points x1, y1, and x2, y2, from the distance formula, we saw that we can view these as two vertices of a right triangle where my sides are going to be y2 minus y1 and x2 minus x1. Now, the hypotenuse itself, I can view the hypotenuse as actually being part of a line that runs between those 2 points. So I have the hypotenuse, but it's really a line segment. And the hypotenuse itself, the line itself, well, I can talk about the slope of the line. And this is another quantity of interest. And I can characterize this slope by the ratio of the vertical distance to the horizontal distance. And so that's the basic definition of slope. We're going to define slope as the rise, that's this vertical distance, over the run, that's this horizontal distance here. And so we'll define slope this way. But when we calculate it, the rise, that vertical distance, is y2 minus y1, and the run, that horizontal distance, x2 minus x1, and so we can define slope by this nice compact formula, y2 minus y1, the difference in the y values, the rise, divided by x2 minus x1, the difference in the x values, the run, and we can compute that as our slope. And typically, because the first letter of slope is s, we typically represent slope using the letter m. Now, that doesn't make sense to me either, but it's traditional. So, for example, let's say I want to find the slope between 2 points, 3, -8, and -1, 4. And again, paper is cheap, so let's go ahead and write down the slope formula. The slope of the line between 2 points x1, y1 and x2, y2 is going to be y2 minus y1 over x2 minus x1. And at this point, I'll just compare my slope formula with what I actually have. And so I need x2, that's the x-coordinate of my second point, that's -1. I'll drop that into here. I need y2, that's my y-coordinate, that's going to be 4. Drop that into there. x1, that's my x-coordinate of the first point. That's going to be 3. That gets dropped in. y1, that's my y-coordinate of the first point, and that'll get dropped into here. And now I can simplify this expression. This is 4 minus -8. That's 4 plus 8. -1 minus 3 is going to be -4. And let's see, 4 plus 8 is 12, divided by -4, and I can simplify that quotient, and I get a slope of -3. Well, there's a couple of useful cases. If I have two lines that are parallel, then they're going to have the same slope. And if two lines are perpendicular, then the product of their slopes is going to be -1. So let's say I have 2 points, a equals 4, 1, b equals 2, -3, and I have a line that runs between these 2 points. This is a line AB, and I'd like to find the slope of a line parallel to AB and the slope of a line perpendicular to AB. Well, in order to answer that question, I need to actually know the slope of the line AB itself. So I have the 2 points on the line. I can write down the slope equation, m equals y2 minus y1 over x2 minus x1. Again, paper is cheap. We might as well go ahead and write down this formula here. And again, I'll compare what I want with what I have. x2, coordinate of the x-coordinate of the second point, x1, x-coordinate of the first point, y2, y-coordinate of the second point, y1, y-coordinate of the first point. So I have -3 minus 1, that's the difference in my y-coordinates. 2 minus 4, that's the difference in my x-coordinates. And the slope of the line, after all the dust settles, is going to be 2. So the line AB has slope 2. A line parallel to AB will have the same slope. The slope is going to be equal to the same number. No excitement there. Perpendicular lines are a little bit more complex. So let's see, I have a perpendicular line. Well, the product of the two slopes is going to be -1. So I know one slope is 2. And the other slope is going to be, well, whatever I get from solving this equation. So 2n equals -1, so n is going to be -1 over 2. And so that tells me that the slope of a line perpendicular to AB is going to have slope -1/2.